Head-Driven Parsing for English to Indian languages, machine translation, and the authors already uh, Pavan, Kurariya, Prashant, Chaudhary, Jahnavi, Bodhankar, Lenali, Singh, Ajai, and Kumar. And our area research is basically natural language processing, especially subset is machine translation and tree adjoining grammar. This is basically rule-based system, and we will gradually go to the training set. So this is the outline of the presentation: background and motivation, introduction, research environment, experiment with tree set, future scope, conclusion, and our references. So basically we are working in tree adjoining grammar and machine translation last 14 to 15 years, and this is our recent research, which is this is current. Bidirectional is not a new, it is continuity of the research. We have already published in last 2 3 years 4 or 5 research paper in different conferences. So these papers and their materials is also available online. So basically, tree adjoining grammar has become the powerful grammatical formalism to processing the large scale grammar. And the parser is software program that try to understand the structure of the source language, basically human language. And the parser can be used in different natural language application. One of them is information retrieval, sentiment analysis, machine translation, and these are the few examples. So the basically our motivation is because uh, traditional parser encounters several limitations and intricacies subtitles for the natural languages, and struggle for the understand and long-term establish the long-term dependencies. So these are the basically issues with parser. The complexity of the parser very high. End of the presentation I will show you the visuals of the inside of the parser. And the capability of the parser is however parser is like our we have already developed the traditional parser, that is left to right parser, and this is directional parser, so where we have converted in bi-directional. So basically this research present bi-directional head-driven parser, and it's enhance how this research head-driven parser. This is work from the left to right and right to bottom, or top to bottom, and bottom to up. So we basically bi-directional parser facilitated, and we are using in translation from source to one language to another, especially for English to Indian language machine translator context. This is based on the Lexicalized Tree Adjoining Grammar, and we are combining the bidirectional parser with head-driven approaches. So this is basically picture of our machine translation application, where we are giving the source sentence, and there's a pre-processing stage. There's several modules come into the pre-processing stage, like we have handling the depth patterns and number marker, noun marker, phrase marker, and out of the vocabulary words. And after that, pre-parser come to the picture. Pre-parser, we have labeled the data like pause tagging. We have developed the pause tagger, then chunker. Then we use the translation engine. This is a core translation engine, and this is the R parser here. The parser actually analyze the structure of the source language, and on the basis of structure that convert the structure into form of trees. Trees is nothing actually. Basically, it's symbolize the in different combination of nodes, roots, all these things, and it's represent the entire sentence. How two lexical items or two part of a speech tagging are connected to each other. This is described this. After that, we have also developed the generator, and generator generate the output of the parser, and after the synthesizer module. This is a basic picture of our machine translation application. Now I would like to focus our parser. So parser is basically this is the tree adjoining grammar is like grammar formalism, that is set of 5 tuples, that initial symbols, start symbols, then set of initial and auxiliary trees. This is basic tree adjoining grammar. So this earlier parser actually parse from the left to right and top to bottom. We have just experimented the approaches, and we have tried to. This is very actually parser is actually have complexity and like taking lots of time for complex sentences. So we are converted the parser into the bidirectional parser. The bidirectional parser actually parse from the top to left to right, and also right to left. And it's basically have three set, like initial symbol, then the prediction that is coming the next target, and the use of multi-threading, multiple parts we have also uses. So this is the basic demonstration of bidirectional parsing, how parsing is actually happen. Like red, you can check the each node, it's predict the.
Dr. Pavan, sorry for my interruption. Your slides are not moving.
Is it visible, sir? Now snapshot
Is visible and but not moving. Can you stop the screen and share your entire screen? Then only it will be visible. Yeah.
sir,
Now
is it moving now?
Yeah, it's moving now.
So have you seen this slide? This is very important slide actually.
Yeah, we can see the slide.
Yeah, so this is basically the snapshot of the parsing algorithm, how parser predict the parse on the initial tree and the left to right. So this is the basically bidirectional parsing. And the research environment I would like to. So this is VTech. We already have research paper on this. This is tools and virtual lab where we have experiment the parsing related activities. And this is our tag maestro, where we've designed the trees for initial auxiliary trees, and for each part of speech tagging we have developed the grammar by using this. So this is the our basic. I will take the one example and try to make it the how it's work. So example is the input sentence. Input sentence, then and build the emperor palace was beautiful. We pre-process the sentence, and pre-process is the nothing like we identify the tokens, and we phrasal marking and all this. Then we identify the part of speech tagging. We used to extract the label the data. We have our own part of speech tagger we have already developed. So you can see the indexing with design, then pt the categories of the each tokens, and these tokens now converted to the bidirectional tree vector. And for each tokens with indexing, we have some sort of trees that will be qualified on the basis of probability. And after that, these three will go to the parser, and parser try to build the structure. This is the basically parse derivation, where you can see the how this design token is connected to the like by, and all these tokens are. This is created the derivation tree, and all the basis of derivation tree we give to the generator, and generator is try to give the parse drive tree, and the on the basis of drive tree is analyze the grammar. On the basis of grammar to generate the output. So currently we are using the English to Hindi language. So this is the English English sentence, and with the help of bidirectional parsing, we convert the derivation tree, and with the help of generator, we can directly translate it into the Hindi language. In this case, we can use any Indian language. We just have to create the grammar, some sort of trees, and after that lexicon item, and with the set of lexicon item, we can convert the one language to another language. In this instance, we have taken English to Hindi language. And this is the basically inner picture of the how parser is predict the this dot traversal. Each tree has four dot LA, LB, RA, RB, and how these predict the. So NP, NP is for the initial tree for the nouns, and We have also used the now experimental with tree bank. So we have created the tree bank already used with our virtual research environment, and with the help of our tools, tag tree creation tools. So we have created the multilingual tag trees, and these are the some creation we have done for this particular research and our project. So part of a speech we have developed done some language wide part of a speech for Hindi, Urdu, Marathi, Odia, Bengali, Gujarati, Bodo, Tamils. So we have parts actually English to Indian languages like Hindi, then Urdu, then Marathi, then Bengali. Number of trees like this is the number of trees for some languages we have 230 trees, then other languages we have 120 trees, then other languages we have 300 trees. This is the actually then transfer grammar. Transfer grammar is nothing the source to target mapping. So we have some source to target mapping part of speech tagging, and this is the basic law. An experimental setup we have used the our virtual machines where we have Linux system, then Xeon processor. We have used the web application as a JBoss, and as a database we have used MySQL 6.0 version. Initially, we have taken the 15,000 sample sentences and given to the parser. We have used our earlier developed parser and the bidirectional parser. So this is the basically 11,500 sentences is successfully parsed, and out of 11,500 sentences, 4,531 sentences has multiple parse. Actually, earlier our earlier parser predicting around 6,500 multiple parts, but due to the bidirectional parsing we can also reduce the multiple parts, and 300 sentences we have analyzed have giving better output than our earlier parser. So this is basically our experimental summary, and earlier parser is taking to parse the 15,000 sentences it was taking like um, 120 minutes, but current parser is taking 40 minutes. So even performance also improve because as we already told you the parsing is bidirectional. So this is basically the giving the statics of the how it will work, and the basic conclusion of this our research we acknowledge the barrier researcher. We have also studied the how earlier tech parsing improved by other researcher, and what is the so we can already study this, and we have limitations we have studied, and we have demonstrated the bidirectional head driven parsing significance and how it can be used. And in case of today's we are using the lots of LLM and neural networking kind of models. We have also studied is how these parser can benefit the neural machine translation current scenario, and actually for the LLM we required lots of data and lots of corpus, but in case of our bidirectional parser we required to like limited data set, and we need to have some our language expert create some grammar, and on the basis of this we can parse the source to target language. And also in case of neural machine translation case, there's some we can't control the some intricacies of the language, and we can also benefit the neural machine translation model with the help of bidirectional parser, but cross context learning, and we can improve the model even with the help of this. So this is our references, and we are also acknowledge the work previous work. This is research based on our Joshi's work that is introduced in 1975, and after that several researcher has worked in to improve this. So thank you, sir. Now I would like to